Okay, we got two sources. I'll call them source 1 and source 2, giving off sound, and got some receiver some distance away, make that somebody's ear, and the sound is coming to that receiver from both sources at the same time. Now, if they were coherent, we would get interference effects. For instance, if there were two single frequencies, you would hear beats here. The intensity would be greater than the sum of the two intensities sometimes, and less than the sum of the two intensities other times. But we have two incoherent sources, and we're told that that means that you simply add the intensity, the two intensity levels, to get the total intensity, which is what that means, that they're incoherent. So we're given information about the levels. So sound level 1 is equal to 10 decibels, and sound level 2 is equal to 15 decibels. And we want to know what the combined level is going to be, and it's the intensities that add, not the levels. Our formula sheet tells us that either L is equal to 10 dB times the natural log base, well, the log base 10 of the ratio of the intensities. So let's solve that for the intensity. Divide both sides by 10 decibels and raise 10 to what's on each side, and I'll have 10 to the 10. I think I'll call that L0. Let's back up. I'll call that 10 decibels L0. L0, by definition, I'll call that 10 decibels log of I over I0. Okay, then I'll divide both sides by L0, switch sides, raise 10 to what's on both sides. I wind up with 10 to the L over L0, and that would be I over I0. So I'll multiply both sides by I0, and I got an expression for I. So let's see what we got here. In other words, I1 is equal to I0 times 10 to the L1 over LO. And I just defined LO to be 10 decibels, and this we know is, well, it's given on the formula sheet. Let's put it that way. I think it's 1 times 10 to the minus 12 watts per meter squared. I2 is I0 times 10 to the L2 over LO. And here we go. I is equal to I1 plus I2. So I is equal to I0 times 10 to the natural log of 1 over L1 over L0 plus I0 times 10 to the L2 over LO. So I can plug that, I think I will. I'll plug that into the total intensity level is going to be, I'll call it L total. You want to call this I total. L sub t for L total and I sub t for I total. That's equal to L0 times the natural log of I total over I0. So that's equal to L0 times the natural log of I0 times 10 L1 over LO 10 to the L1 over LO plus I0 times 10 to the L2 over LO, all divided by I0. Alright, it's pretty clear that the I0's cancel. I've got the sum of two logs, and that's not something that we can simplify, so let's go ahead and evaluate LT is equal to LO. I think I'll write that as 10 decibels. Just made up that expression for that 10 decibels that occurs in the definition of the loudness, or the sound intensity level based on the intensity. And then 10 to the 10 decibels divided by 10 decibels plus 10 to the 15 decibels divided by 10 decibels. So LT, go ahead and plug all that into the calculator, and I get 16.193 decibels as the intensity, or the intensity level of the total. So just not very much more than 15 decibels, even though there were two sound sources there. By the way, let's see. Together, I would say the intensity well, I guess I can't tell how much the intensity went up there. So if one's 5 decibels more than the other, I would say the intensity's got to be at least a factor of 2. And a factor of 2 makes, compared to just one of them. So if we were at 10 decibels, yeah, it's more than a factor of 2, so we go up. If we add the second one, we're going to go up more than 3 decibels, and we did do that. So I guess in that sense it makes sense. The result makes sense. So what we're saying is the two sources together are louder than either one, but not really much louder than the 15 decibel one by itself. And I think that's about all I could check, that it should be greater than 3 more than the 10 decibels. Alright, so it does come out in just decibels. The units work out. What I'm trying to take the log of is unitless, so the units work out there. So all the stuff that's easy to check checks out well. And I would say the loudness of the combined loudness is only 16.193 decibels. You can definitely see that the sound levels don't add. If they added, we'd have 25 decibels, but it's the intensities that add, and then once you figure out how they add, you gotta determine the intensity level from that.